Hello, my name is Rich Howard, owner of Architectural Builder Supply, and the project that I'm working on now is making the wood underliner that you're gonna see when you go to the Mexican restaurant and you order fajitas, and that cast iron griddle comes out so hot that it's impossible to touch that. But there's always a piece of wood the griddle sits on. So what we're making actually is 50 of those underliners. Okay, so I took a lap and obviously came back, realized that I forgot this vector is good, but we need a vector for the pocket. So we're going to come in, oh, there's a way to do this. This is going to be the ball bit. I need a vector now offset to the inside of this, half of the diameter of this bit, and it might actually need to be a little bit bigger of 3/8. Testing is going to tell us how we have to tweak that because I need my pocket. So let's copy, let's paste. You'll notice Control C, Control V. Now you see it change. It's got some black in it. That means there are two stacked on top of each other. That's how you know. So this, what I want to do, I don't want to move it. I want to resize it. Yeah, link X and Y. Let's go for it. Let's move the width in. It's got to be 3/8. Minus 0.375 equals apply. Let's try this. Minus the X, minus the Y. Yeah, I think we finally got it. Okay, let's take a look. Let's measure it. 3/8. 3/8. You can tell I don't do that often. 3/8. Now this might have to get tweaked a little bit because of the overlapping of the bits. 3/8. Okay. Meaning I might have to take and stretch this out ever so slightly. We'll see what that bottom finish looks like. So this is going to be the vector of the pocket. This is going to be the vector of the ball groove. This vector's got to go to the other side. So the only thing we're doing on what's the top are these two vectors. Let's go with our pocketing toolpath here. Close. Vector is selected. We're going to pocket. Start depth is 0. Now, how deep are we going? I had measured that before, and I thought it was about 3/8. I'm comfortable with 3/8. So we're going 0.375. We're using that same compression end mill bit. I'm going to select it and make sure it's tool 5, which it is. We're going to try these. We're going to select that. Oh, let's remove it. 2 passes, 3/16 per pass, I guess. We're going to try it. We're definitely going to climb cut this, I think. Ramp in, project. We're going to call this just pocket on top. Calculate. It's not awful. All right. If you are enjoying this video, please click thumbs up or like, and also please consider subscribing to our channel. Let's move on to the rest of the video. We got a new bit to set up. This is going to be a profile. We're going to do 375, but I'm going to be on the inside of this one. Now we need a new bit. This is where we're going to set up a new bit. Let's take this compression end mill because I'm going to want to use, I think, a lot of the same cutting characteristics. Let's copy it. Let's rename this to 10 AB ball bit. Okay, we got a 10 AB ball bit. This is 3/4 diameter. It is 2 flute. Call it hardwood. Copy. Okay. So this is going to be set up by me 09/28/2024. This is an Onsrud 52-397B 2 flute ball nose upcut. That's what we're going to call this. Ball nose upcut. Now we're going to go back and grab some cutting data. Downloads cutting tool data. This is a 52-397 hard plywood again. I think we've got that page open. 52-200. I'm checking this out because we've got a greater diameter. So 0.009 to 0.011. 009 to 011. That's a pretty fast spindle. All right, where are we going to put this in the tool? Put it in tool location 9. That's okay. It's at the end of the ATC. It's furthest away from where we would zero it and drop it off, but that's fine. We'll leave it in 9. 009, 001. Apply, select 2 passes. Let's go with 3. Okay. So 3/8 deep with a really big ball nose bit, 3 passes on the inside of the line. Ramp, yeah, we'll ramp. Okay with all this. Ball nose profile, calculate. Ah, it's not an end mill. It's a ball nose. Yeah, what are you going to do? I screwed up because I didn't change that it was an end mill, and I'm thinking, boy, there's something I forgot. All right, so it's a 3/4 ball nose. This is an Onsrud 52-397B ball nose 0.75 up spiral. Number of flutes 2. Create settings. Pass depth. I'm going to leave all that. This is all inherited. Apply. Select. Yeah, I realized when I was going to go in and visualize this that it would be looking wrong because it was an end mill and not a ball nose bit. Edit passes. Let's make this 3. Ramps and ball nose profile and calculate. All right, so let's close. Let's save. Let's select these 2. Let's preview these 2 tool paths. This is the 3rd pass on this pocket. Slow it down. Let's bring it in. Now we're going to go to the ball. Yeah. Oop. Hey, doesn't look awful. I think that dog will hunt. Okay, close. We're going to draw it once and then we're going to array copy toolpath and it's just going to throw them all down here. If you are enjoying this video, please click thumbs up or like, and also please consider subscribing to our channel. Let's move on to the rest of the video. Okay, so now we're going to move this to the other side. Move to other side. Okay, so this is the top. Actually, the other side is easy because it only uses this vector, but we're going to run two different tools on it, which I think is going to be okay. Okay, so I like that. Okay, we have flipped it. The reason I know that we flipped it, I got distracted. Your rulers turn to this yellow color, plus your other vectors are now gray. So it's also flipped the workpiece over, which is exactly what we want. Let's select that vector. What are we going to do? We need to run a V-bit over it. That's going to mean a new bit for us. We'll have to see if we can find cutting data from Amana on this. We should be able to. We're going to do a V groove. We're going to do it on the line. We're going to do a profile. That profile is going to start at the top and it's going to go down. So what we'll do is we'll go down 0.727, 0.727, the thickness of the material, minus 0.156. Let's do 530 seconds. So we'll go 0.571 down into the workpiece. Okay, now we've got to select a new bit. Select. We need a V-bit, big V-bit, 90-degree inch and a quarter. Let's take this V-bit, let's copy it, let's rename it, AB Supply V-bit 2-inch. It is a 90-degree. So 09 dash, I'm just putting the date, dash 2024, me, this is an Amana, 45732, 90-degree V-bit, 2-inch diameter. Chip load, max RPM is 14,000. Let's see if we can find a chip load for this. Okay. Two flute 90, chip load per tooth. Yeah, Chris Burns always says, when in doubt, 007, James Bond. I have never found him to be wrong. So I guess hardwood. Yeah, two flute 90. Yeah, we're going to have to slow that down like 2 inches a second or less. Let's say if we go 100 inches per minute divided by 60, 1.66 inches per second. Let's get that plugged in. Two flute, 0.006 chip, 50, 130 inches per minute speed. Max RPM, the instructions say that's the max RPM. So let's copy all of this. Two flutes, 90-degree, diameter is 2-inch, cutting pass, blah, blah, blah. Chip load 004. We're going to need to make that bigger. Inches per second. Yeah, okay, I like it. 1.66. 005, and I want to hit 006. Yeah. 8250 RPM, 0.006 chip load, 1.66 plunge rate. That's fine. Tool number 11, that ain't going to work. It won't know where to go. It's funny because it's a 9-tool changer. We'll stick this in tool position 8. So right now we've got 5, 9, and 8, I think. Stick this in position 8. Apply. Select. It's going pretty deep. I'm going to change this to 4 passes. I don't feel any need to push the tool at this time. We're going to be on the inside of the line. That's good. We'll ramp. This is going to be V-bit profile on bottom. Project. Calculate. No toolpath generated for government. Check tool can fit into vectors at machining depth. All right. On the line. No, we want that on the line. That was close. Yeah, inside the line would obliterate the vector. That should be the problem. Inside the line would obliterate the vector. Yeah, that's what it was. Now we're looking at the underside of this. Let's preview the visible toolpath. We're moving really slow. Speed it up. On the line. Now, our next and final tool path, well, it won't be our final tool path, but what it should be, and I'll explain that when we get to it. Save. The next thing that we should do now is that upcut bit, that compression 6123 MW. Now we're going to do a profile, but this time we're going to be on the outside of the line. This cut depth is going to be 0.727 plus 0.05. That's really important. We have to remember the 0.05 because of our tabs. Our tabs have to be big enough to not get obliterated. So 0.777, we're going all the way through. Outside of the line, boy, there won't be much left there to cut. We're going to start this at 0.5. We'll do it in 2 passes because it's already been mostly cut. It's already been substantially cut. So we'll start at 0.5. The V bit will have substantially cut all that because we're on the line. Climb cutting. Now we got to get a bit selected. Select the bit. This is going to be a 6123 MW. This is going to be a 3/8 compression end mill. Maybe it's this one. Yeah, awesome. A 3/8 end mill. Yeah, I've already got this tool built. 6123 end mill. It's 3/8 diameter. Let's slow it down, Hanky. Get that chip load up. 5,200 RPM, 3 inches per second. We'll see what that looks like. 2 flutes. Tool number 4, that's fine. So we're going to go 4, 5, 8, and 9. So it's going to be 5, 9, 8, 4 in terms of the bits in order. I've got to load those bits in those locations on the tool changer. Tool number 4, apply, select. If you are enjoying this video, please click thumbs up or like, and also please consider subscribing to our channel. Let's move on to the rest of the video. Final profile on bottom. Add ramps. Oh, we need tabs. Oof. Add tabs. Length 1/4 inch. Thickness 1/8. Yeah, we could try it. Edit tabs. What do you think? Let's put one here. Let's put one here. Let's put one here. Let's put one here. I don't want to put over here because when I sand it, I just want to sand a straight edge. Close. Calculate. Yeah. Whoa. Yeah. Thank you for the warning. I was about to really screw the pooch. So we're starting at 50 thousandths. We're going to go 0.777 minus 0.5 equal. Yeah, cut up. Our passes changed. You got to keep your eye on the passes. I'm either doing something wrong or the software is wonky. I'm sure I'm doing something wrong. Tabs are still there. We're going on the outside of the line. Calculate. Yeah, we know. That tab is an eighth of an inch. So there's going to be 0.0775 left over. Check tool can fit into selected vectors at machining depth. Yeah, it can. Tool's long enough. On the outside of the line, there should be no problem with this. Let's make this 0, and let's make this 0.777. Our pass has changed again. Let's change it to 2. Okay. No toolpath generated for current parameters. Check tool can fit into selected vectors at the machining depth. Okay, I am not sure what we're doing. I'm Google searching as well. Let's just do it together. Okay, it's saying verify that you have closed vectors. Let's racetrack that. It's open. That's the problem. It's an open vector. It said something to me. Final profile on bottom. Let's go back to the 0.5. Let's go back to the 0.777 minus 0.5 equals compression end mill. We're on the outside of the line. We're going to climb cut it. We've got tabs. Edit tabs. Add a tab there. Add a tab there. Add a tab there. Add a tab there. Close. Calculate. Okay. Kind of looks like something now, doesn't it? I don't like the modeling resolution. What I want to see is how thick that edge is. Right there. Yeah, right here. It looks all right. Looks heavy. Looks nice. It's not awful. So then what we'll do is we'll nip those tabs out, and they might be too thick. I might make them smaller, but even NASA had to start out with Gemini missions. Preview all sides. Let's get that speed up. Here's our 3/8 bit. All right, on the other side, I imagine. Okay, we're doing that truing cut. Yeah, it doesn't leave it on the other side in this preview. Pocket on top. Just increasing the speed. Oh, it should be the ball nose bit. There we go. Speed it up. Resolution any better? Yeah, for sure is. A lot better. Let's flip it over because I wanted to see the lip that will end up being on the top side. Yeah, it's better. The tab looks like it'll be good. We might change that. I don't want to be you got to make sure the piece is going to hold without breaking loose. I don't think it will. It is plywood. But yeah, looks nice. It's not awful. Okay, there's actually going to be another tool path, and let's go to it right now. So I've been saying that there would be an extra tool path, and here's this piece of material. The extra tool path is going to be giving the client something extra. And it could be a bust. It's not going to be a waste of time. But what's really awesome is let's try to put their logo on the bottom of this. They're probably not going to hate that idea. So let's switch back to the screen view and let's see if we can pull this off. Thank you for watching, and if you've enjoyed this video, please click thumbs up, please subscribe, and maybe even send the video to someone that you know. Thank you.